Thank you for joining today's I Am Online, the monthly webinar focused on identity and access management, brought to you by InCommon and Internet 2. We're excited to see all of you here. My name is April Motley, and I am the communications lead for InCommon, and I'm happy to help host this hour of community and collaboration. In just a moment, I'm going to turn things over to our wonderful moderator, but just a couple of administrative notes as we're getting underway. We'll be taking questions and comments live using the Zoom Q&A function. So if you would ask your questions using that function, and you can do that throughout the presentation. We want this to be as interactive as possible. Feel free to post messages in the chat as well. We will be monitoring chat, but if you can post your questions using the Q&A function, that would be wonderful. We're also recording this webinar, and it'll be posted to our YouTube channel soon after the webinar. As I said, our moderator is pretty fabulous. So without further ado, I'm going to pass the virtual podium to Heather Flanagan to introduce our topic and our presenter.
Great, thanks. And I think we'll get the chat sorted shortly. So if you're trying to go there, it'll be ready soon. So yes, my name's Heather Flanagan. I wear many, many hats, but all of them touch on identity standards and collaboration. And so I'm here as your moderator, and I want to introduce Tim Capelli. Tim is a member of the identity standards team in the Microsoft's identity division. He's currently working on identity coexistence with privacy-related changes in browsers and operating systems. He's also working on security event and signal sharing for zero trust. He's also working on the rapidly evolving world of FIDO2 and WebAuthn. Tim participates in working groups at the OpenID Foundation, the W3C, the FIDO Alliance, the Centralized Identity Foundation, and the IETF. Some of you may know him as an advisor to Internet 2's EduRoam Advisory Committee. Previously, he was Aruba's identity and policy architect, working on federated identity, secure wireless roaming, zero trust, infrastructure context sharing, and policy programmability. And he's worked with a bunch of industry groups, including the Wi-Fi Alliance, the Wireless Broadband Alliance, the OpenID Foundation. And today, given that impressive resume, he's here to talk about Passkey. So we had passwords, and then people added SMS for multi-factor authentication. Then they added push notifications, and all these additions have added complexity to the environment. So many people have been working on trying to figure out another way, and that's where WebAuthn comes in to try and minimize that complexity and do away with passwords entirely. So WebAuthn is a joint standard between FIDO and the W3C, and it does magic, but that magic is really challenging to deploy, and it doesn't solve for everything. And that's where Passkey is coming in. So today, Tim is going to introduce us to Passkey, the problems it solves, and how it can help transform higher education's reliance on passwords. So we've got several breakpoints during this session where we're going to stop to take any questions you have. As April mentioned, feel free to queue your questions in advance in the Q&A feature of Zoom. And with that, take it away, Tim.
Awesome. Thank you, Heather. You can hear me? All right, cool. Hi, everyone. Thanks for joining, and thanks for the intro, Heather. I want to start with something that, I'm not going to throw stats at you, like you've seen all of the password day statistics around passwords, but the reality is we're still in a world where, hackers aren't breaking into accounts, they're just logging in, right? Like there's still significant, the majority of accounts on the web still do not even have second factor enabled. And that's a huge problem. And we had to decide as an industry, do we solve for getting people to enroll in second factor, or do we try and blow all this up and actually just make the primary way people authenticate phishing resistant so they don't need it at all, right? And so hopefully by the end of this, you'll see kind of where we came out and what this whole Passkey thing is all about. I want to do a quick refresher on FIDO2 and WebAuthn if you're not familiar. So as Heather mentioned, WebAuthn is a specification that's in the W3C, so it's a browser-based spec. That's mostly what you as an identity provider or a relying party actually work with. The other half of the protocol set is called client to authenticator protocol. That's what actually deals with talking to like the platform authenticator in your device or a security key or anything external, right? So most people don't have to worry about that, so we don't really talk about it too much, but those two specifications together make up the FIDO2 protocol stack. And the reasons we like FIDO2 and why it is largely regarded as the prime authentication method for the web and apps is 6 properties, right? One is it's a 1-to-1 unique credential per service, right? So there is no opportunity to share a WebAuthn credential, a FIDO credential with more than one site. It is literally bound to a site. So if I have 15 sites that I have accounts on, I have 15 different WebAuthn credentials. That is a very powerful security property. There is no opportunity to reuse that credential. It's standards based, right? Those 2 standards I mentioned, I think everyone in the EDU community, I think, understands the value of standards. Standards make things work together. They are, the reason you can plug in your device and charge it in any part of the world across every country. It's the same reason your phone can connect to a Wi-Fi network anywhere in the world, right? Standards make everything work. And obviously signing into websites and apps across the world, we need to have a standards-based solution. It is phishing resistant. That's the #1 security property, right? I caution saying it's phishing proof. No, nothing's ever proof. Someday in 100 years, something will happen, but currently it is phishing resistant and is the strongest authentication method that we have today. It is asymmetric cryptography without a PKI, right? It actually uses public key, private key pairs, but there's no PKI. There's very little infrastructure required that you're used to with other things like X509 certificates. And the last one, which is probably the most important at this point in time, it is natively supported on every platform. Every device that shipped within the past, I'm going to say 4 years, and even earlier, has native support for FIDO2. And that is huge, right? Without support, we can't actually use any of this. So that is why we're kind of now coming together to think about how we get people to adopt it. So what does phishing resistant actually mean? As I mentioned, that's the most important security property, but what about FIDO2 why is it phishing resistant? And the 2 key properties are proximity, right? You actually have to have an authenticator within local proximity of the device to actually authenticate, right? So if I'm using, let's say, Windows Hello or the Apple platform authenticator with Touch ID on a MacBook or the fingerprint reader on Android, that is actually built into the device. So you have proximity, right? So that built-in device, automatic proximity check. Then when you get into what's called a roaming authenticator, so a security key, let's say, it could be USB, it could be Bluetooth, or it could be NFC, right? You still have to be physically proximate to the device, right? So USB, obviously you're physically plugging it in. NFC, you have to be within very short range to tap, and Bluetooth low energy is a very short range, generally same room, right? So that is a very strong property of phishing resistance, is local proximity. The other half of this is that the concept of origin binding. As I mentioned, each site actually has its own credential, right? There is no way to share credentials. So if I have an account for login.captoso.com, that's the relying party, and my username is tim@mymail.com, if I try to use that on login.captoso.com, that'll work, right? It is the exact same match to the origin. If a website login.captoso.com.site.xyz, which is a very common pattern with phishing, is to make very, very long names so that the tail end goes off screen, it wouldn't work. It doesn't match. It's not the same origin, right? So the platform, the client, will not allow this credential to be exercised. Same thing, myaccount.com, completely different origin. And the last one, I'm going to say X, and you might be saying, well, that looks exactly the same. Let me change the font on that. It's actually login.captoso.com, right? So that wouldn't match, right? Something that, the characters, and you can do all kinds of fun stuff in the address bar as an attacker to mask a site. And this is what allows users to get phished so easily, right? So none of those would match except for the first one, which is the origin it was created on. And that is incredibly powerful and one of the strongest pieces of phishing resistance. So we've had FIDO2 and WebAuthn for a number of years now. It's been baked into the platforms for a number of years. Very large enterprises have rolled it out. Some consumer sites have rolled it out. The most notable in the US would be eBay, Best Buy, GitHub, but they're still very, very low. And so the challenges that have led to that low adoption have been that those roaming authenticators, those USB security keys or NFC security keys, right? You still generally need one of those to actually set up your laptop or your desktop, right? Like if you actually want to use Windows Hello as your Windows platform authenticator, how do you strongly prove your identity to Windows to set that up? You still need some strong credential, which leaves us essentially, leaves us back to needing to have a password on the account, right? So all roads lead back to a password just to set up the stronger authentication method. So that is a huge challenge. Even if you do have a roaming authenticator, they cost money, right? These security keys, the cheapest one is this blue one from YubiKey, still about $25, list price. And at very large scale, that adds up. It's cost, right? It's in many folks' eyes, it's unneeded cost. Even if you do have one of these, even if you do offer these to consumers, they don't want to buy them, right? So if you give them one and then we tell them, well, you really should have two because, what if you lose the first one? They're not going to want to go buy one, right? So it's not an easy solution. Like giveaways were kind of the way originally, like, oh, you sign up for, maybe eBay will give away some security keys, but it doesn't scale, right? You really realistically need to have two of them in case if you really want to remove things like password sign in or SMS sign in. The funny one right now is, everything else on a user's keychain, and I actually meant to bring my keys over. The only thing I have left on my keychain is my mailbox key, right? Like my apartment, I can use my phone, the bike that I ride in Boston, I can use my phone, right? Everything else that's on a user's keychain is moving onto their phone. So we can't ask people to hang a new thing on their keychain when their keychain is going away, right? So it's an odd paradigm to start asking users to do that. As I mentioned, device loss is still an issue with these roaming authenticators. As much as I can remove it and plug it into a different device, which is super helpful for bootstrapping, if I lose this, well, I lost access to my account, right? Hugely problematic. The other one from a user visibility standpoint is the terms WebAuthn and security key are incredibly confusing to users. If you go to bestbuy.com right now, I'm super happy that they implemented WebAuthn. It's amazing, but it says sign in with WebAuthn, right? Like, and users don't know what that means. It's a developer term. It's an API name. Should never be exposed to users. But what else? We can't get mad at them because, like, what else can they say? There's no universal term for all of this. And security key, same thing. Like users kind of think of this as a USB dongle, or it's not a term that is just like Bluetooth, right? Like it doesn't have that same user relevance and understanding. So where we're going, right, and this is the vision for Passkey, right? We need, and this is kind of to help you understand how we got to this end state, right? We need something that is as easy to use as a password. Can't be any more difficult. It is easy for users to recognize and understand. It leverages a user's existing investments, right? They don't have to go buy anything new. It is durable across device loss, right? No single loss of a security key should lock you out of your account. And it is geo-aware and inclusive. That's huge across the world, right? Like these security keys are never going to be feasible in many parts of the world due to cost, getting these into the country, crypto, all these things that work against these type of solutions. So I want to introduce you to Passkey. The first thing you'll notice, it is a lowercase p. We've noticed a lot of the tech press and stuff capitalizing it like it's a product. It's not, it's a noun. Password, passkey, just a new name for it. And it is a password replacement that is safer, easier, and faster to use, right? So it is, we'll see throughout this presentation, we're not necessarily saying it is the same security as the FIP certified $200 security key, but we think for the masses of users around the world, this is the password replacement that is safer and easier to use. So if we think about what a passkey is versus the old world, right? What used to be just called a FIDO credential or a WebAuthn credential. The new piece here is that we want to make your passkeys available on all of your devices in the same ecosystem, right? So if this is me and I have a passkey for login.captoso.com, let's just keep that example going. That is actually now going to be part of my, let's say, my Apple account or my Google account, right? Just like a password, right? So these credentials now sync up to your keychain, right? Your cloud keychain. They're end-to-end encrypted. They're fully secured like your other user data. And now they're available on all of my devices that are signed into that same account with iCloud Keychain or my Google account or my Microsoft account, right? So in this case, I have two devices, let's say a phone and a tablet, those are both signed into my account, but that passkey is available on both of those devices. This is awesome, right? It's super easy for a user to use. We'll do a demo in a little bit to show you how user-friendly it is. And a user never has to worry about losing access to either of these devices, because if they provision a new device to this account, they come back, right, after proving who they are and all that fun stuff. Now, the question often comes up, like, what do I, like, that's cool. It sounds like I'm locked into one of these ecosystems, right? And the answer is no. One of the second half of this initiative is actually also allowing these to work outside of ecosystems, right? Inter ecosystem. And so what that means is if I have a laptop, let's say that's in a different ecosystem, so let's say a Windows laptop, and I want to sign into a site on that laptop, we actually have added a new capability to the protocols that actually allow cross-device sign-in, right? So I can actually now use my phone to sign in with a passkey across device without the key ever moving from that ecosystem, right? So it's very, very powerful. It allows you to sign up pretty much everywhere. And it allows you to work across these different ecosystems. This is going to be very common. This cross-device scenario is going to be very common in education and enterprise, where let's say your laptop is actually a organizational asset, and maybe iCloud Keychain, as one example, is disabled because obviously you don't want corporate, university stuff synced to their work account. But the user still needs to they still want to sign into their personal stuff, right? They still want to access their Facebook account in their browser, right? So this is a great way to be able to still sign in, even though the laptop is not signed into that same account, right? So we have a lot of flexibility across both scenarios to enable both of these use cases. Now, one of the things that one of the design things I mentioned was we wanted to make this as simple to use as a password manager, right? So we took a lot of inspiration from password manager user experience. So this is just a quick mock-up, right? We actually are adding the ability for essentially the passkeys themselves to enumerate up into a dialog box when you're at the login page for a site, right? So you no longer have to do this guessing game. This is very common with consumer federation, right? So like I signed up with a Facebook account and then I come back and I thought I used my Google account. So I click Google and it thinks you're creating a new account, right? It's that awful user experience. This will hopefully avoid that and be a very seamless user experience, because the user will see, oh, I already have a passkey for the site. I tap on that, I do my biometric, and away I go. So it is a familiar experience for users. It is dynamic from a developer standpoint. You literally just add one HTML tag to your username field, and you get this capability from the browser and the platform. It is privacy preserving. This box is rendered by the browser. So the relying party, does not know that any accounts exist until the user taps the account, does the gesture, biometric or PIN, and then completes the flow, right? So it is still very privacy preserving, which is a core principle of FIDO. And as I mentioned, it's a very simple change for relying parties. Add a tag to the username field, away you go. Now, in terms of that cross-device experience, right? What does that actually mean? Like I explained like what it solves, but what does that really mean for a user? The goal is that a mobile device can bootstrap the other ecosystem. There's two scenarios where we see cross-device being valuable, right? What I mentioned where, one device is in a different management state, or the sync is not allowed to be used on that device, or a kiosk, right? Where you generally don't want users to be setting up local credentials, right? So at a student, like a student union type setup where they need to print something, you don't want users setting up a local credential on that device. So the cross-device flow is super handy for that. You just sign in very quickly and then sign out and you're done. There's no persistent relationship between those devices. The other piece is the bootstrapping model, which I mentioned, right? And this is a very familiar, if you use security keys, this should be a very familiar experience today where, you sign in, let's use GitHub as the example. You sign into GitHub using your security key and you do the biometric check, whatever it is. And then the next step is you're prompted to say, hey, now enroll your local device, because we don't want you to have to pull out your security key every time, right? So this pattern already exists today. And really what we're doing is we're replacing security key with phone, right? So we actually want you to start with your phone. So let's say I'm on a brand new Windows device and I have my Android phone in my pocket with all my accounts on it. I obviously don't have any credentials on the Windows device yet. I go to sign in. Sorry, forgot to animate that. I access the site on my Windows machine and I use my mobile device to sign in. That goes great. And then the site will actually say, hey, now why don't you create a passkey on this Windows device that you don't need your phone every single time, right? And the user can obviously click out of that. They don't have to do that, but we think a majority of users don't want to be pulling their phone out every single time they want to sign in, right? So it's a nice balance of organic passkey creation, right? It's very user friendly. It's just a prompt. They click OK, do their check in a way, and it also allows a flexibility across those devices. So I'm going to pause here for questions. I see some coming in. There's sorry.
We do have questions.
So the origin binding effect if the organization changes its domains. That's a great question. There's two answers there. Oh, I'm supposed to click answer live. So one is that's often solved using what I call same party federation, right? You could federate off to an origin that has that realm still, and then you could prompt the user to re-enroll with a new credential, right? Which is fairly seamless in this model. So that's one option, or you could just re-provision from day one, right? And I know it's not a perfect answer, but the security model is bound to that origin. So most folks generally do a temporary federation off to the old origin and then prompt the user to re-enroll in an inline flow, super quick, away they go, and they're on their way. What if I want to get all of my passkeys out of Apple and into Microsoft? Great question. That is something we are solving in phase 2. We need to ensure that the security promises we are making as platforms can survive the transfer process. So that is top of mind. We have no interest in owning all of your passkeys. We envision a world where, just like today you have password managers, we envision a world where there will be passkey managers, right, that can plug into the operating system. And if you want to use, let's say, X password manager to manage your passkeys, we want to enable that vision. It's just we could only do so much in the first release. So that is coming. Your account guards access to your cloud keychain. When will the account holding the keychain be guarded by a passkey? That's a great question. I can't answer for the other companies, but we plan to allow a passkey to sign into your Microsoft account as the primary factor. So you could use a passkey that's in your Apple account to sign into your Microsoft account. Where is the passkey stored? So the passkey is stored in, the deep answer will depend on the platform, but every platform ultimately has a keychain where secrets are stored. And so they are end-to-end encrypted and stored in that, more or less from, if you were to look at it from Microsoft, Google, or Apple's lens, it's an encrypted blob. We can't see anything. This is the passkey blob. And only you can decrypt that like any other end-to-end encrypted data. And that an important point is that just getting access to your, let's say, your Apple ID does not give you access to your passkeys, right? So you still need, because it's end-to-end encrypted, you need to have either a recovery credential or knowledge of one of your old devices to then decrypt the end-to-end encrypted blob, right? So it is very, very secure. Is this the same passkey mentioned by Apple? Yeah, so passkey, as I mentioned, is just a generic term, right? Passkey, password. It is an industry thing. We worked on it with Google and Apple. It's not an Apple passkey or a Microsoft passkey or a Google passkey. It's just a passkey. We are all implementing the same standards.
Great. I know we have a bunch of other questions in the chat, but I know you also have a lot more to get through. How do you feel about your timing?
The next thing was a demo. So let me do these 2 questions and then we'll hop into the demo. Oh, there's a lot. Okay. And then encrypted. What are they encrypted through? We are going back to password. I will defer Rohit to, every platform has their own documentation on how they do end-to-end encryption. I don't want to answer on their behalf, but pretty much all of your sensitive consumer data that's tied to these accounts is end-to-end encrypted. How well will this work with 80-year-old parents who share a cell phone? That is a great question. You can have multiple passkeys with different accounts on the same phone. That is certainly, shared devices like an iPad, for example, are very common. So there was nothing to prevent that from working on those devices as well. Another question, what's the future of the main cloud account? Okay, that was the same question, I believe. What happens when a user leaves the organization and have used this for their Facebook and Google? I'm not sure if you can clarify that one, like it's not stored like with the organization, right? It's your consumer account that you have with one of the companies that makes your devices, right? So if you were to leave one of those, like if I switch from all Windows and Android to Apple, right? There will be a migration process at some point, but it's not tied to your organization. All right, let me hop into a quick demo. I do want to show you that this is all real and not vaporware. It is a demo though, so I appreciate if it doesn't go well. You guys appreciate that. So we have a fictional bank here called TriBank. There's so many windows from Zoom. Sorry. Share screen. And can you see my full screen?
Not yet. There we go.
Okay. You see like a phone and TriBank.
Mm-hmm.
Sweet. All right. So in this case, right, for this example, I'm going to start on my phone. Hopefully it works here. Let's see. I can put my password in correctly. All right. So I'm going to start on my phone, and like most users, they're going to go to a site and start with a password, right? So I'm going to sign out. Sorry about that. And I'm going to sign in as Lisa. And I'm going to sign in here, right? That's probably a very common flow for most users. They're already using a password. Maybe there's like an SMS that comes into play here, but for the sake of the demo, we're in, right? And now that the bank has detected, hey, you're on a phone that supports Passkey, it's very quick to just have a prompt here that says use a Passkey. And so I'm going to say create a Passkey, and I'm going to create it. I'm Elisa, and you can see here the account it's being stored to, and I go ahead and click continue. The next thing, it's going to go blank just because it's a security prompt, but I am actually going to do a biometric check on the device. Sorry, the screen render is very far behind. What's going on? But in theory, once this comes back from black, you should see that I am signed in. There we go. Oop, creating Passkey, and we're done. Okay. So now I have a Passkey on my Android phone. So I'm going to go ahead and sign out, and I'm going to sign back in using the Passkey. And it's as simple as, in this case, I actually have two Passkeys for this bank because I have two different accounts. So I'm going to select Elisa. I'm going to do my biometric check on the device, and I should be signed in. Seems to be when it goes black, it takes forever to come back. There we go. And I should be signed in. Boom. All right. So there we go. So now I have a Passkey on my Android phone, which is now in my Google account. And in theory, if I were to get a new Android phone, maybe I upgrade or I get an Android tablet, that Passkey for TriBank for my account will be there. Now, what happens when I want to sign into TriBank on my Windows machine right here? So this is what I mentioned to be the cross-device flow. So I'm actually going to click sign in with the Passkey. And the first thing you'll see here is add a new phone. This will eventually not say Android. As I mentioned, this is some of this code is early, but it'll actually just say add a new phone. And I'm going to do that. And for the first time I do this, I just need to scan this QR code because it's the first time I've had this relationship with these two devices. You wouldn't see this QR code from then on out when you wanted to do a cross-device sign-in. Now on my phone, you'll see connect with the QR code. Yes. And remember, this computer is checked, so I don't have to do the QR code every time I want to do that. Then I go ahead and click allow. I'm going to select an account. So I want to use Elisa, and I need to do my biometric check. And I am done. And now I should be signed in on Windows. And now it should pop up and say, hey, do you want to use a passkey on Windows? And this is the part that sometimes doesn't work because I have so many of the same accounts, but we will see if it works. And it is spinning. Come on. Da, da, da. Spin, spin, spin. All right. Well, while that's going, I'm going to now show you the same exact thing with, oh, there it is. Finally. Sorry, it's super slow when I mirror for some reason. Okay, so now that I've signed in for my Android phone, the bank says, hey, we detected the device you're on locally is actually also passkey capable. Why don't you create a passkey on this device so you don't need your phone? So I'm going to do the same thing. I'm going to create a passkey on this device. This will trigger Windows Hello. And since I'm using my camera, I can't do the camera sign in. So I'm going to use my PIN. And I'm going to create a passkey. And now I'm in. So now next time I sign in from this device, it should go right to Windows Hello. And I don't need my phone. There's Windows Hello. Again, I can't use my face because I'm presenting. And I am signed in. So now I have a passkey and connected to my Google account. I have a passkey connected to my Microsoft account. So on both of these devices or any device in these ecosystems, I can now sign in seamlessly. Don't have to worry about losing access to these passkeys. Because before, if I had used Windows Hello on Windows, that, you know, if I got a new Windows machine, it would have been gone, right? They're local to the device. So now, just for the sake of showing an Apple thing, I want to show you real quick what this would look like for an iPhone. So on this case, the iPhone already has a passkey enrolled. I just want to show you what that cross-device flow would look like here. And what you should notice in all of this is that the experience is very similar, right? One of the goals here is to normalize all of the OS plumbing and UI to make it much more consistent across the devices. So I'm going to go ahead and sign out. And I'm going to say sign in with the passkey. I'm going to cancel out of actually the Windows Hello dialog because I actually don't want to. I want to use a phone this time. Unfortunately, I don't have an easy way to clear that. So I'm going to cancel. It really doesn't like when I'm mirroring here. It's slowing down. My fan's kicking in. All right. I will come back to this at the end if we have time. It's getting pissed because I have the camera going here. So let me go back to the slides. Actually, let me pause. I think a question came in. The bank enrollment flow over the phone was initiated by the bank due to bank functionality, correct? In other words, there's nothing the user to, correct. Yeah, so the bank detected that you were on the bank essentially said, hey, you started with a password. We think you're on a device that supports Passkey. Do you want to do it? That doesn't have to be the way it's done, right? A user could actually go in and go into their account settings like they would add SMS second factor, right? And they could say enroll a passkey, right? So it doesn't have to be automatic. We recommend that it be automatic because it's a nice way to like promote higher security on the account. So let's break it down again. So we started on Android, right? And I started with a password. As I mentioned, TriBank detected passkey support. This is actually a very easy JavaScript command. Is user verifying platform authenticator, is UVPA, is user verifying platform authenticator available, right? It's a long query, but it returns back true or false. And at that point, the relying party said, hey, I would like to create a passkey. And this is just standard WebAuthn, right? Not a lot has changed between if you were doing WebAuthn before, like this is all just vanilla WebAuthn with a new use case. So TriBank said, hey, I'm going to actually create the passkey, calls a WebAuthn, and what happens is Android is then invoked to show you the platform authenticator, right? So this is the platform Chrome that you saw pop up. The user selects continue. And we did a verification check, right? So it'll be a fingerprint, a face check, or a PIN, depending on what the user has set up. And at that point, the user has now upgraded to a passkey. So now TriBank may actually say in their logic, they may go remove your password or prompt you to remove your password. That's all kind of business logic that happens in the background. That's your choice as the relying party. And it's something we think over time, you know, maybe you don't ask the user to remove their password right away, but maybe you see them successfully using their passkey for months, and then you ask them to remove it at that point. So then we went over to Windows, right? We started with a passkey from Android. We scanned the QR code. As I mentioned, this QR code will only show up once per machine as long as you check remember this computer. If you uncheck this remember this computer, you will see the QR code every time because the devices don't actually link together. So we scanned the QR code on the phone. We perform user verification on the phone. When I did the demo just now, you actually saw a screen just before that because I actually had 2 credentials. When you only have 1 credential, it will use the only credential available. And you sign in, and now Windows Hello is invoked, and we enrolled with Windows Hello. We did a user verification check on Windows, which in this case, it would have been face, but I was presenting. In this case, it used PIN, and away you go. Windows now has a passkey. All right, there is a lot more questions coming in here. Let's see. Typical management pushback starts with, what if a device is stolen or cloned? Does that mean the thief has access to everything? If the device is stolen, you would still need to be able to unlock the device to access that credential container for that user. So there's really nothing different than today if you have like any other keys or anything else tied to that account. So remote wipe would blow all these away as well. Is there a managed list of sites such as banks that support Passkey? Not quite yet. This is fairly new, right? You won't actually see this in GA until the fall. But we do imagine we believe the adoption curve is going to be quite high because it's going to be natively baked into every operating system. What about resistance to man-in-the-middle attacks, as we're seeing against MS? So that earlier in the slides, right? The origin binding and proximity are what make it resistant to man-in-the-middle attacks, right? So that's what makes it phishing resistant. Most of the things you're seeing with MFA today, if you were using a passkey, it wouldn't be possible. Does the spec allow a site to specify minimum PIN or biometric requirements? No, not through the API, but on a managed device, that's something you'd be able to control via your normal management policies. Okay, and now I'm into the other one here. How does this relate to Microsoft Entra Verified ID? I'm going to wait till the end because that's more of a product-y thing. I was trying to keep this somewhat neutral. So you mentioned a possible migration between Apple and Android. What if I use both? I have two passkeys? Correct. So in the example you just saw, I now have a passkey for TriBank in Windows, in my Microsoft account and in my Google account, and that is perfectly okay. Now I have two passkeys. It would be the equivalent of having, the two password idea doesn't really exist today, but it would be the equivalent of you having two security keys against your accounts. Okay. Do passkeys need to be rolled over regularly like we do for passwords? No, they do not. And so there is no process to do that. To make sure I understand, so TriBank made the decision to enable Passkey, but the Passkey is associated with the user's Android phone. So a university could enable Passkey on their internal website. An employee could use their managed device provided by the university, but its student could use their personal device to sign into the university website. Is that right? Yes, but both scenarios could be managed or unmanaged. It doesn't. The management of the device doesn't necessarily come into account here. It's the user's account where the credential is stored, right? So if a user is using a password manager today for their primary credential, that is more or less that nothing really changes there. It's the exact same paradigm. The thing that is shifting, right? And I have a slide for this at the end, but we can talk about it now. The piece that is shifting is we only added second factor to accounts because the first factor was phishable, right? That was the #1 reason why we added OTP, second factor, all these authenticator apps that have a miserable user experience. We did all of that because the user could be so easily phished on their primary credential. Now that the primary credential is phishing resistant, the question for the industry is, do you still need any of that stuff? Our current positioning is, except for very high security use cases, there is no need for those less user, that additional friction for users. But I'll talk about in a minute. There is some additional security components that are helpful for higher security environments. In the event of a password update, is the passkey revoked, user triggered to re-verify? Well, there wouldn't be, the password and the passkey don't necessarily relate, right? In theory, once the user has a passkey, there is no more password. So I guess the question is if the passkey is revoked or changed, would the user be triggered to re-verify? That is something you would do on your end, right? You as the relying party would say, this user changed their credentials, I want them to re-authenticate. How did the mobile device communicate the successful auth to TriBank and the cross-device bootstrap we just saw? So this uses a new, the CTAP protocol, which is used currently to talk to security keys. We've enhanced that to support what's called the hybrid protocol. And the QR code, all the QR code did was creates the relationship between the two devices. What happens is the very, very high level version is there is a Bluetooth advertisement that is used to more or less pass a tunnel identifier and a half of a key. And that provides two functions. One, to prove proximity. As I mentioned, proximity is critical to phishing resistance. So now I've proved that these two devices are proximate. And it also sends the tunnel ID that allows the browser and the device to connect back through a WebSocket, right? So there's a direct connection there.
So I know there's a whole bunch of questions still left to go, which is great. I love the engagement. But looking at time, do you need to?
Yeah, let me finish the slides and then we can go back. Yeah, so it's 20 minutes left. So as I mentioned, right, like I think there's a lot of questions about like, well, what about higher security use cases, right? And in EDU, that could be students who are also employees. IT admins and faculty and staff, right? So in the rest of the industry, there's, regulated, so financial, government, and healthcare. And then there's also the high value consumer accounts like politicians, journalists, executives, and influencers, right? The typical blue check marks on the web, right? Who have high influence and like their account is hacked, there could be actual like world war. So we do have a solution for these use cases. And what we've added is something called the device public key. And the idea with the device public key is that in addition to this like synced key that works on all of your devices, that you as the relying party, the identity provider, can request a device bound key on top of that, right? So if we think about what that looks like, I have tim@example.com passkey in my cloud account. It is on all 3 of my devices. Login.example.com could actually say, hey, I would like a device public key every time you sign in. And what happens is each of these devices creates a second key that is tied to the device that is then passed with the passkey so that for example, that this key, the key over here from my phone, the passkey came from a different device than the red one here from my laptop, right? So it's used as a trust signal, right? It's so in a way you could pump this into your risk engine to say, hey, maybe I want to take additional action because this user is signing in from a new device and they're a privileged user, right? This is not something we expect or would like relying parties to use for basic sign-in. It's really for those high security use cases like an IT administrator or someone with access to maybe like student records. Those would be examples in EDU. In terms of where this all falls in the security spectrum, right? So we believe, password is obviously all the way to the left. And we still do, at least I will say for Microsoft, we still strongly believe in security keys for the use cases that need them, right? Security keys will remain the strongest option, but they have significant trade-offs, right? And that's what we're trying to solve here. So left, you have password, right? You have a single device passkey on a security key. And then, what happened is everyone layered on OTP to try and make the password less phishable. And then in the middle here, we think between password and single device passkey, we have this multi-device concept where the credential actually syncs across the user's devices. And then somewhere between, if we were to say this is 0 and 100, multi-device passkey is 50, at about 75, we believe this DPK idea is about a 75, somewhere between the sync only and the single device. Square in the middle there is the multi-device passkey plus DPK to provide some additional assurances. And so before we go into the questions, I'll just wrap up the slides. The 4 key points I'm hoping you take away from this. This is a drop-in replacement for passwords, right? And it will start rolling out in the next 12 to 18 months. It is cross-platform and cross-ecosystem, one of the very key points. It is a familiar UX for users, right? It'll be very, very user-friendly, both from the credential selection to cross-device. Hopefully the demo for the part that worked, hopefully you saw how easy that was to use. And there is an option for higher security use cases. All right, so let me jump back into, they're still rolling in here. All right. What about shared computers and kiosks where you would like to log into an account but not enroll in Passkey? So that is exactly the use case for the cross-device flow, right? So you would be able to configure the machine to say, like the shared device to say, hey, only support cross-device, and don't allow a local credential to be created, right? So that's exactly one of the use cases for that. What commitments have Apple, Google, and Microsoft made to the long-term success of this? This is a core service like Wi-Fi, right? It is in everyone's best interest to eliminate passwords, like globally, right? Passwords are the single biggest threat to security on the web. So I will speak for Microsoft. We are 100% committed. We have been committed for over 7 years. We're one of the only IDPs that allows you today to remove your password. So I can tell you we are committed. Is Passkey available for shibboleth SSO? What happens if a user? So this is all, that's a great question because it highlights layering, right? So Passkey is a credential type, right? So it really has no direct relationship to shibboleth as a protocol, right? Like it is a credential type, just like a smart card, just like a WebAuthn credential, just like a password, just like a SMS, right? So if your IDP uses shibboleth, you can implement WebAuthn to support Passkeys. What happens if the user account is deprovisioned? Same thing that happens today, right? There's no change for the actual account management side of it. right? So the credential is removed from the account, and then you can do whatever you choose after that. How do the user and the various RPs handle a theft or compromise of a passkey? The user can remove the passkey from their account, just like any other second factor credential. It would be the equivalent today as if the user lost their security key, right? They can go remove it from their account. You as an administrator of the relying party could remove it from their account. When the user wipes their device, they'll be removed from the account. So there's not a big shift from how that is handled today. What would happen if someone tried to use the QR code before the person who initiated the demo? If the person tried to use the QR code, they would be signing into their account on someone else's computer. So it's not in their best interest to do that. What is the process when a passkey gets created, the password gets removed, and then passkey is lost? So none of these are at the protocol level, right? So that is something in your recovery flows, not much has changed. We're trying to give you an option for a credential that has higher recoverability potential than previously, right? Like today, like even if you're using something like the Duo app or Authenticator, you still have to re-provision that you have to go through a whole process to get that set back up. The odds of you losing a passkey are slim to none, right? Unless you actively go delete it, right? Like it is in your account. It is in your control. If the user deletes it, sure, you would need to help them get back into their account. But the natural loss of a passkey, the odds are very slim. And you said, let me highlight, user destroys their phone. That is why these passkeys sync to your account. So if you do lose your phone, when you get your new phone, you didn't lose access to your account, your passkey comes back. If my phone just died, what is the fallback mechanism if I have no device to cross-device authenticate? Charge your phone. I don't know. I like that. Again, that's not a new problem, right? If you didn't have your security key, if you used your password but didn't have a device to get your SMS, right? Like so, some of this weren't necessarily design goals, right? There's the assumption that you have access to a device. Is there any functionality for shared passkeys? For example, moving from a password manager that makes use of shares? Yes, it is not something we at Microsoft really like. We don't like the idea of shared passkeys. The pattern that you should follow, right? Like so, the idea that you could just send a passkey to your friend for your Netflix account, right? The reality is what you really should do is just add a second passkey to your Netflix account, right? Like sharing is not necessarily needed. Sharing is very much a legacy idea because of the shared secret component of a password, right? So if I the use case I was going to oh, me and my partner need to sign into the same electric company to pay our bill, right? The answer is not to share the passkey. The answer is you both enroll a passkey to that same account, right? So you each have your own. That's the pattern that we would like to at least evangelize. Whether that is the reality of how people adopt, that is certainly an open question, but that's what we'd like to at least recommend to the industry. Will there be support for command line environments like Unix shell? Generally, the way command line works with Fido is that you pop out to a browser and then do a callback to the CLI. That's how the GitHub CLI works. There is technically nothing stopping you from calling directly. The challenge becomes, what is the RP ID? What is the origin, right? So for one use case that is available, sorry, let me back up. One use case that's available today with security keys is you can actually put an SSH key on your security key. That is something we would like to think about maybe in a V2 or a V3 for the passkey. So, we do want to make a passkey available via SSH as well. How is proximity determined if my cell phone is on the carrier? I assume you're talking about the cross-device flow. So as I mentioned, there's a Bluetooth advertisement, a Bluetooth Low Energy advertisement that is required to establish proximity. You can't actually connect to do the flow unless you receive this packet. So you have to be within, technically it's 30 feet, but it's really realistically 5 to 10 feet for it to work. All right, and then I'm going into the chat now. Sorry, I'm a bunch of windows here. I don't remember where I left off here. Okay. I see how this works on a personally owned device. How does this work in a shared device environment? So that's, again, that's back to the cross-device sign-in. Any type of shared environment where multiple users are going to be signing into a machine, we recommend the cross-device flow. Just like today, before Passkeys, we would recommend to use a security key. How about Passkey integration with SAML Federation IDPs? I think I answered that already, but I'll say it again. Like this is an authentication method, so there's no direct relationship to the Federation protocols. It's just something an identity provider could enable as an auth method. Looks like that one was a duplicate. For enterprise security level, how does disable revoking token passkeys work with this architecture? So you as an identity provider, just like you could revoke an auth method, right? Like you could, in theory, you can go into your IDP today and say, I want to revoke a certificate tied to this account, or revoke a phone number that is used for SMS, right? You'd be able to disable or revoke a passkey from the IDP side. How is the passkey bound to the device? What prevents a malicious user from exposing a passkey from my laptop to their laptop? Each OS will do slightly different things, but we have the expectation that they will be key wrapped to some form of hardware on the device, and they are also just not exposed to the user. Like it's not like a certificate that you can go into like MMC or keychain and right click export, right? So that they're not user exposed. How is the session managed? Is it vulnerable to session hijacking? If you could clarify what you mean by which session are you talking about would be helpful. Thank you. As in, this is in common. Are you working with Shibboleth? I think Scott maybe is answering that. Scott said SSO products like Shibboleth don't automatically support WebAuthn or Passkey. They have to implement that support, and they need a full suite of backend management, UI, portal tools for managing them. That management component is the difficulty in just implementing Passkey and Shibboleth, as we are not web developers with the ability to build and maintain complex management UI. We need help to do that. Yes, that's a great answer. And the other thing is that as part of this initiative, we are ramping up on developer tools. We actually have a site that will be going live, hopefully in the next few months, called howtopasskey.dev. There we will have very purpose-built use cases. You know, the last thing that I want personally, as someone who works on the WebAuthn spec, the last thing I want is anyone to have to go read it, right? Like that's super deeply technical. They're hard to read. So the goal is that this site would allow you to get everything you need to implement this, and even have maybe an SDK that you could drop in. There's some very, very strong SDKs out there that are already adding all of the pieces needed to support this new passkey paradigm. Is the intent for passkey to eliminate the need for both password and MFA? Yes, that is for a majority of users around the world. Yes, if you, you know, the thing I like to say is that if you only added a second factor because you could be phished with your first factor, then you only need a passkey, right? If you added a second factor because you needed stronger assurance about the user and other security properties not related to phishing specifically, then maybe you continue with having, maybe the first time you see this user on this device, you prompt them for something else via, let's say, a push notification. But for the vast majority of users, this is a drop-in replacement, and that is all you would need. Tommy, I would not recommend, that is an old doc. I would not recommend using that at this point. Scott said an open standard for interfacing with those backends would be a huge win for open source identity products to allow more plug and play with infrastructure. But no, yeah, Scott, we should ping on that. Not sure what we could standardize there, but we should definitely, we could talk about that. Okay, a few more just came in. With user verification, should passkey be considered multi-factor? Something you have and something you are no? Yes. And the next question for the industry, you know, as NIST starts to reevaluate things in like revision 5 of 863 is, what does multi-factor mean anymore if, again, the primary factor is no longer phishable? Okay, and since we have a second, I will answer the Microsoft Entra Verified ID. Entra Verified ID is verifiable credentials. They are not necessarily, they're complementary, right? So I can imagine a world where you have a brand new account for an organization and you need to get access to it. And instead of you getting a temporary password or some other thing that exists today, you know, maybe you present a verifiable credential from an identity proofer, or you present a verifiable credential of your mobile driver's license. And then the next step in that process is you create a passkey for your account, right? So they're very complementary. On the topic of 2FA a path with passkeys. In your demo, use Windows Hello and needed to validate biometrics. Is that a second factor and can it be required, or is that just a feature of Windows Hello? All WebAuthn credentials in the Windows platform require user verification. Even if you as your relying party ask us to not do user verification, we will do it because we think it's super important. I hope that answered your question. Have you worked with NIST to establish assurance levels for Passkey? NIST is about to release version 4. We missed the cutoff for version 4, but we are actively discussing with them. And then one more. Am I pointing into CK is plugged into a particular problem? Yeah. Okay. Oh, out of breath.
That was a lot of information, Tim.
I'm sorry, my camera's not working. Literally, I'm running. So here's the problem. Just for full disclosure, I am running like an incredibly alpha build of Windows, and I'm running Chrome Canary, and I'm using my webcam while trying to use Windows Hello. So that was just like a bad combination, apparently. So I apologize. You can't see me, and I apologize. The iOS demo didn't work. I can assure you it works. I will actually send. Let me see if I can grab it real quick. I will grab a link. The video just dropped today of we doing this entire demo end to end with all platforms. They just posted it. Let me find it so I don't forget. And here it is. Copy link. Send to everyone. That's a cool demo to watch if you want to see the entire thing. It's actually doing more or less what I showed you, but it'll show MacBook, Windows, iOS, Android, the whole process. So.
Thank you, Tim, for sharing that and all the other resources that you shared with us this afternoon. We appreciate it. Let me see if I just have, as we're entering to our final moments together, I just wanted to end on a couple of notes. I can share my screen here. Great. So again, many thanks to Tim and Heather for the great discussion and presentation. Also want to say thanks to my colleague Kelly Farrow for providing technical support this afternoon, and to all of you who attended, whether you posted questions or just listened in. We really appreciate you being here today. The community and the opportunity for collaboration is what makes InCommon go, so we appreciate it. Before we sign off, a couple of things. You will see a Zoom survey pop up as you're leaving the webinar this afternoon. We ask that you would please take a moment to complete that. We value your feedback. It helps us determine future programs, so please complete that. Our next I Am Online will be in September. If you have feedback about today's presentation or I Am Online in general, please let me know. Again, my name is April Motley. My email address is there. Again, we will be making the slides and the recording available. And finally, I do want to let you know that we have extended the expression of interest period until the end of the month for InCommon's Collaboration Success Program. With that, we thank you again, and we will see you in September for I Am Online again. Have a great rest of the day.